dealing with vector addition. So I have a few different problems on the board that we are going to talk about. But essentially when it comes to a vector, so a vector is like a line with a direction. So when we look at one of these vectors here, so a vector has a certain distance, but it also has a direction and where it's going. So for example, it would be similar to saying maybe that you have a mile, but not just saying, hey, that's a mile. It's a mile headed northeast. So it has a distance and it also has an angle attached to it. So when it comes to adding two vectors together, in my mind, it's very similar to giving directions maybe to someone. So if you're trying to tell someone, hey, go down the road, you know, north going this way for 2 miles, and then you're going to turn over here and go 3 miles down that way, and you're taking all these pieces and you're adding them together for a total distance. But when it comes to vectors, vector addition, so what we want to kind of think about is what if we wanted to get the shortest, quickest way to get somewhere? And the shortest, most efficient way how to get somewhere is straight there, a straight line from one place to another. And that's what vector addition looks like. So instead of heading one direction for so long, turning and headed a different direction, we want the shortest route, which would be from our starting point down to our end. And that is what the resultant, our vector answer, is going to look like. So when it comes to adding these two vectors, what we want, so we're going to go with A and B, which is already set up for us, and then we're going to piece together C and D ourselves. So our answer, our resultant vector, when it comes to these two here, would be from our starting point to our ending point. So our resultant is going to look like it's going to start right over here, our starting point for this example, and it is going to go all the way straight to our ending point. And I'm going to just call that vector C. So if we add vector A plus vector B, our resultant is what would we get if we went in a straight line from our starting point all the way to an end. And that's really all there is to vector addition. So if I'm going to look at example B and I'm going to add vector A and vector B together, my resultant is going to start at my starting point and it's going to end at the end of my vector right over here. So this vector C is my resultant. It really is as easy as that as far as vector addition graphically. We will talk about how to do this algebraically in another video. So if we're looking at example C, we need to piece this together ourselves because these vectors are not connected. So this is how you piece it together. So we're going to start with vector A. So I'm going to redraw vector A. It looks like this. And what I'm going to do is I'm going to tack on vector B to it. So vector B needs to start where vector A ended. So vector B is going to start right over here, and vector B goes off in this direction looking like that. So my resultant is going to start from vector A all the way down to the end of vector C, and that's what that one would look like. So let's do that again with example D right over here. So we're going to start with vector A, and vector A looks something like this. And we're going to attach vector B to it. So vector B is going to start at the end of vector A, and it's going off in this direction like that. So our resultant is going to be from the start of vector A to the end of vector C. And that's how you graphically add vectors. Otherwise, that's it for this video.